Hi everyone, today I will explain about Karnaugh Map. And Karnaugh Map is a tool for simplifying combinational logic with up to 3 or 4 variables. It is an alternative to minimize the number of logic gates that are required in the digital circuit. It can replace Boolean reduction when the circuit is large. So first, when you write the Boolean equation in a SOP sum of product form, then place each term possibility on the map. So the map is made up of a table of every possible SOP using the number of variables that are being used. So if the variable is 2, then 2 times 2 map is used. If the variable is 3, 4 times 2 maps is used. If 4 variables are used, then 4 times 4 maps is used. If the variable is 5, the 8 times 4 map is used. Creating Karnaugh Map. First of all, you need to determine the minimum number of cells required to contain all possibility of the variable. Then the cells are usually labeled using 0 and 1 to represent the variable and its complement and are entered in gray code to force adjacent cells to be different by only one variable. Ones are read as the true variable and 0 are read as the complemented variable. Alternatively, cells can be labeled with the variable later, such as like this. This makes it simple to read, but it takes more time preparing the map. This is the example of 2 variable Karnaugh maps. This is the example of 2 variable SOP Karnaugh maps. This is 3 variable Karnaugh maps. 3 variable Karnaugh maps list the possible combinations as a pair of variables against a singular variable in a cell graph. Then AB will be here, then C will be here. So for the output which has 1, we will write out the output A prime, B prime, C, because A0, B0, C is 1. So just do it the same way for all the 1. And this is a 4 variable Karnaugh Map. This is the example of 4 variable Karnaugh maps. Karnaugh Map property. To go from one cell of the map to an adjacent cell will only require one variable to change. So when moving on the map, you can only go right, left, up, down, or never on a diagonal. Also, the map folds around itself, so the going from a cell on the top right to the one of the bottom right only change one variable. Karnaugh Map loopings. The next stage with Karnaugh Map is to simplify the equations. The expression for output y can be simplified by properly combining those squares in the Karnaugh Map which contain 1. The process for combining this one is called looping, or normally we call it grouping. So loops must be in a power of 2. For example, looping groups of 2, 4, 8. So grouping should be as large as possible for maximum simplification. So to be exact, loops pair eliminate 1 variable, 2 variable, octet 3 variable. So overlap are allowed in loops, provided every loop has at least one that is unique. So this is the looping for group of 2. So this is group of 2, group of 2, group of 2 up and down. So this is group of 2 and this is the side grouping. This is the looping group of 4. So here straight, horizontal, square, and a corner grouping and a side grouping. This is the looping group of 8. In the center, side, up and down, and right, left and right. So the Karnaugh Map simplification process. Step to follow in using the Karnaugh Map method of simplifying a SOP standard form Boolean expression. So first of all, construct the Karnaugh Map and place 1 in those squares corresponding to the 1 in the truth table and place 0 in the other square. And secondly, examine the map for adjacent 1 and loops those ones which are not adjacent to any other ones. These are isolated ones. And next, look for ones which are adjacent to only one other. Loops any pair containing such one. Then loop any quads that contain one or more ones that have not already been loops, making sure to use the minimum number of loops. Loop any octet even if it contains some ones that already been loops. Loop any pair necessary to include any ones that have not been loops, making sure to use the minimum of loops. Form the or sum of all the terms generated by each loop. So for this for this image, you can see the grouping of square, 2 and 1. This one is square, horizontal, and these two grouping. Yeah. So for K-map don't care, some logic circuit can be designed so that there are certain input conditions for which there are no specific output level, usually because this input condition will never occur. This will be the don't care condition, where we literally don't care what the output is no matter the input level. In the K-map, don't care are indicated with asterisks and can be treated as either 1 or 0, or simplification purpose, or just ignore entirely. This is helpful if it allows us to form larger groups that would otherwise be possible without the don't care. So we assume a logic function where the desired output is 1 for input ABC equal 101 over the range for 000 to 101. We don't care what the input is for the output possible input. When mapped to a 3 variable K-maps, the resulting graph is like this. Then these two will be like don't care condition. So if we admit this 2 is 0, then the result is only grouping the 1 1. So the output will be A, B prime, C. So this is easy. This is the simplest solution. So but if don't care cells are taken into consideration, two possible loops can occur. One using SOP and the other with POS. This we consider this as 1. So we'll group these two as a two variable grouping. So the output will be AC. AC means like this one at A. So this one 1 1 C. So AC. That's all for the lessons. Thank you.